in this section, 3.1, we're going to be finding relative maximum and minimum. So basically, what we're going to do is we're going to be taking a lot of time, or we're going to, in calculus in general, you spend a lot of time looking at the behavior of a regular function. And a lot of times, looking at the behavior of a regular function is going to be using the function itself, but not graphing it all the time. Now, we're going to use this graph in this problem right here to kind of illustrate what we're trying to do. But two of the major things that we will be working on is being able to find a minimum or a maximum value on a function. So what we're going to do is we're going to use derivatives to do this. So basically what we have said is that if I say that f prime of x is equal to 0, we say that the derivative means slope. So that means that we can write that the slope of the tangent is 0. And that's what f prime of x equals 0 means. Okay? What that also means is that if the slope of the tangent is equal to 0, then that means that we're going to get what we call a horizontal tangent, meaning we have a tangent line that is horizontal, which also has a slope of 0. Okay? So the first thing that we want to make sure is that we understand that the slope is the same thing as the derivative. The slope of a tangent is 0 if it's a horizontal tangent, if the derivative is equal to 0. So the next thing we want to make sure we understand is that if we say that f prime of x, which is, remember, the slope, if that is greater than 0, in other words, if the value of our derivative is greater than 0, then that means the slope of our f of x is positive. Okay, remember, derivative means slope of f of x. Derivative is slope of f of x. If the derivative is greater than 0, the value of it, then that means that it's going to be positive. If f prime of x is less than 0, then that means the slope of f of x is negative. Okay, that's basic. That's just basic overview of derivatives and how they work. And I know that we've talked about this in class a little bit. So let's get into what we're going to actually do. So the first example says find the relative extrema. What relative extrema means, let's find where there's maxes, mins, or possibly neither. Okay, so we're getting right into this. Find the relative extrema of f of x equals x to the third minus 3x squared. So what we will do is we will first find the derivative. So the derivative of f is going to be 3x squared minus 6x. That's easy. Then, to find relative extrema, we need to know where is the slope, which is derivative, equal to 0. In other words, we're going to take our derivative and set it equal to 0. So we have a quadratic here. Therefore, we want to factor. But the first thing we should do is factor out a common factor. So this will be 3x and 3x are common factors here. So 3x comes to the outside, and x minus 2 will be on the inside. Okay, so therefore now we can determine where these are 0. This will be x equals 0, because 3 times 0 is 0, makes the whole thing 0. This portion will be x equals 2. So therefore we know that our relative extrema are x equals 0 and x equals 2. But now we want to define exactly which one of these are. So what we've talked about is we can determine whether something is a max or a min based on what the derivative or what the slope of the function is doing on each side of that value. So in other words, as x approaches 0, on the left-hand side of it, it's increasing. It has a positive slope. On the right-hand side, it has a negative slope. And because it's changing from increasing to decreasing, we naturally have to have a peak. If you go from positive slope to negative slope, it has to have a peak, which means this is going to be a maximum. And then x equals 2, down here, we have a negative slope, or decreasing, and then it changes to positive, so this is going to be a minimum. But let's pretend like we cannot use the graph to see this. What would we do? Well, what I would do is I would draw a number line, and I would plot my two extreme points in order on that number line, 0 and then 2. And what I would do is I would basically figure out what is my derivative at each of these intervals, not at the value. We already know the derivative 0 at these values, but I want to know what is the derivative here, what's the derivative here, what's the derivative here. So all we're going to do is plug in values that we know. So I'll plug in, say, -1. So therefore, I'm going to do 3. Sorry about that. Little mess up here. 3 times -1 squared minus 6 times negative. And this equals a 9, so it's positive. So therefore, I'm going to put a positive right here. Next, I will plug in a 1, because that's between 0 and 2. So 3 times 1 squared minus 6 times 1 is equal to -3, which is a negative. So therefore, I'm going to put a negative there. And then I plug in 3. 3 times 3 squared minus 6 times 3. And that actually gives us a positive 9. So therefore, that's positive. So now what we can then do is say, look, we're going from a derivative being positive means it's increasing, positive slope. We're going from increasing to decreasing, meaning increasing to decreasing, which means x equals 0 is going to be a max. And then we go to our 2, it's decreasing to increasing, therefore x equals 2 is our min. And that's really all we're talking about here for right now. These are what we call local or relative maxes and mins. If there is no sign change, then it's neither. You have to have a sign change. The only way for you to get a max or a min is if it changes from increasing to decreasing or decreasing to increasing. Otherwise, there is no max or min. It would be neither. Okay, so you have one to do on your own here. Let's see how this works out. Same thing as above. Put your answer in. Let's see how you do. So this one was going to be a little bit different because hopefully you found that x equals 0 and x equals 1 were your points, your extrema points. And then you should have seen that we get a negative value for both the intervals to the left of 0 and a negative value between 0 and 1, and then a positive value. So therefore, x equals 0 is neither because there is no sign change. We're going from decreasing to decreasing, so that does not yield us a min or a max. But then we do have negative to positive at 1, so that means it went from decreasing to increasing, so therefore that would be a minimum value. And that's really all that we're doing here. Hopefully this makes sense. I will see you in class, and let me know if you have any questions.